Okay, this is Dr. Holt. I'm going to go over a few of the UT problems that people are struggling with. This problem here, I don't remember the number, but you have a 41.1 Newton object in free fall. What is the magnitude of the net force that acts on the object? Again, you draw yourself just a force diagram. The only force that you would have would be mass times gravity pulling down, which would be, let me get vector, which is going to be the 41 newtons. Coming down like that. And all that is, again, that's just mass times gravity. That's 41 newtons. So that's it. You have no other forces. The answer would be 41 newton. Second one, what's the magnitude of the net force when the object encounters a resistance? 15.7 Newton air resistance. Well, if it's falling, air resistance is going to go back like this. This would be 15.7. In this case, you sum the forces in the y direction. You would get minus 41 plus 15.7. That would give you a value of negative 25.4 is the total force, and that's going up. So the answer is the 25.4. They just make that positive because they're not established in direction. And it also says magnitude. This is what is the magnitude of the net force when it falls fast enough to encounter air resistance of 41.1. Okay, in this case, the only difference is the air resistance becomes 41.7. Sorry, 41 newtons. In this case, the object will reach a constant velocity, and the net force then has to be 0 because the summation of forces in the y direction. You get 41 newtons plus minus 41 newtons gives you 0. A problem here, you have a dock worker loading crates on a ship, finds an 11 kilogram crate initially at rest on a horizontal surface, requires a 70 Newton force to set it in motion. You draw yourself just a simple little picture to illustrate what's taking place. We draw ourselves a quick little 11 kilogram object here, just sitting here. If we apply a 72 Newton force just to get it to go, then what happens is friction would have to also be 72 newtons coming back. Again, it's just because it says in here to set it in motion. Alright, since this has a mass of 11 kilograms, then we can figure out what the coefficient of friction is. If we draw ourselves a force diagram again, we'll have 11 times 9.8 coming down. Grab a calculator real quick, I'll do that. That gives me 107.8 coming down. My normal force would have to go back up. That would be 107.8 newtons. Here, put the units on here. Our frictional force, again, 72 going this way. Oops, make that picture better. And we're pushing 72 here. Okay, by definition, we know that frictional force is equal to normal force times mu. So we take 72 is equal to 107.8, which is our normal force. Solve for mu. So if we take 72, we divide 107.8, we get a value of 0.667. Which is this value right here. Okay, the second part of the problem says after the crate is in motion, a horizontal force of 60 newtons is required. So if 60 newtons is required and the object's already moving, I'll get rid of this. Then what we're going to have is going to be kinetic friction. So we'll draw our force diagram. We'll have 107.8 coming down. We'll have our F normal, 107.8. requires a 60 Newton to keep it moving. Again, constant speed, which is constant velocity. So frictional force must be 60 also to maintain that constant. So all we're going to do is normal force times mu is equal to friction. All we have to do is take 107.8 times mu, set it equal to 60. In this case, solve for mu, and we'll get mu as this value right here. Okay, another problem here. I think we may have done this in class. This one we have a block incline. What's the frictional force acting on the block? Now it says it's at rest, which means it's not moving at all. So we're dealing with static friction. First thing to do is draw yourself let's draw what's taking place here. I usually do this. So if I do that, I have 19.9.8 coming down. I'll draw this real quick here. So get the calculator out again. 19 times 9.8. It's 186.2. This angle here would be your 31 degrees. This would be 186.2 times the cosine 31 degrees. 186.2 times the sine of 31 degrees. Run those numbers. This one's 159.6. 186.2 times the sine of 31. 95.9. I'll make that newtons and newtons. Now we're ready to draw our force diagram. Again, always draw these in the correct orientation. Do not draw these just straight up and down, because it's not going straight up and down. Alright, now this object is at rest, so that means that this value here is going to be 95.9 also. This value here is going to be 159.6. This is going to be 95.9 here from this value here. This would be 159.6. Now, your correct answer is going to be this right here. That's what's keeping it moving. Even though you can take 159.6, which is your normal force, we're going to multiply that by our mu value, which is 0.7. We'll run that number real quick. And that gives me 111.72. What you cannot do is say my frictional force by definition is 111.72, because that means that friction would actually make this block accelerate up, which is impossible. This is the maximum frictional force here. So I could actually like pull down on this thing with a force, and I could keep pulling and pulling until the sum of this and whatever I'm pulling reaches 111.72. At that point, the object will start to slide. But again, this value, this frictional force here will vary depending on how much load is being applied. Right now, it's going to be 95.9 because this force is 95.9 pulling down. Now the question says, what's the largest angle which the incline can have so the masses do not slide down? Alright, to do that problem, we're going to come back to here and we're just going to change this. And the only difference is we don't know the angle here. We're going to make this into theta. We'll make this into theta and make this into theta. Now we're going to change our force diagram too. And everything changed. Basically everything's going to change here. This value here now is going to be 186.2 cosine theta. This will be my normal force, which is 186.2 cosine theta. This value here is going to be my 186.2 sine theta. And now, by definition, we're going to let this frictional force go the largest possible. And it says does not slide, so we're going to do the static. This will be my normal force, which is in this case 186.2 times the cosine of theta. We're going to multiply it by the coefficient of friction, which is 0.7. Now, we're going to let this be our x-axis coming down, and we'll let anything come down be negative. So, some forces in the x direction, set them equal to 0, so it does not move. I will get minus 186.2 sine theta plus 186.2 cosine theta times 0.7 is equal to 0. I'm going to move this to the other side. So I get 186.2 cosine theta times 0.7 is equal to 186.2 sine theta. Now divide this. These cancel out. I'm going to move the cosine to the other side. So I get 0.7 is equal to sine theta over cosine theta, which is also equal to tangent theta. So I got 0.7 is equal to tangent theta. All I have to do is take the inverse tan of 0.7, and that's equal to theta. And when I do that, I hit second tan 0.7, and I get an angle of 34.99 degrees. And that's the answer to that one there. Okay, now it says what's the acceleration of the block? Down the incline, the angle of the incline is 39 degrees. Alright, so go back and work it one more time. Let's just steal some of this so I won't have to do this all over again. Come down to here. Now it wants to know 39 degrees. Now we know at 34.9 it's going to start sliding anything greater than that. So we know it's going to slide, so we're going to be dealing with kinetic friction here. So this problem is really pretty easy. We'll take 186.2 times the sine of 39. This gives me 117.18. Run this number here, 186.2 times the cosine 39, 144.7. Again, force diagram. We'll let this be 117.18, 144.7. This is my normal force, 144.7. Now this is going to be kinetic because we know the object's sliding, so we're going to just do normal force times 0.59. So I take 144.7 times, what did I say, sorry, scroll back up, 0.59 times 0.59 gives me a value of an 85.373, and that's my kinetic friction, 373. Now all you have to do, sum forces in the x. Let's be in the x direction, let this be negative. I get minus 117.18 plus my frictional force, which is 85.373. We just set that equal to our mass of the object, and our mass was 19. And we set that into AX. And just solve for that. So we'll just subtract that. So our net force is 31.807. We divide that by our mass. 19, and it gives this acceleration of 1.6. And I'm going to get a negative value of that, but it just means it's going down like that. And again, that'd be meters per second squared. And that's it. So there's a few problems I worked. I hope this helps you with the UT. Got any questions or anything? Just just text me.